Hello, everyone. Thank you for joining us today for the webinar that we've prepared, Beyond Specs, Navigating H100 Applications and Use Cases. I am Constance Morales. I am PMM AI at Scaleway, and I'm thrilled to be here with you. And today with me, let me welcome Anthony Monthe from Cloud Mercato, founder of Cloud Mercato. Anthony, hi. Hello.
Hi, Constance.
How are you, Anthony?
I'm fine, and you?
I'm good, thanks. And we also have with us today Andrey Drozdov, MLOps engineer at Diabolocom. Hi, Andrey.
Hello.
How are you?
Good, good.
Great. So we're all here to discuss this question about H100, like why H100 is so famous right now, how performant it is, and what it's made for in terms of application and use cases. But maybe before starting on this, maybe some of you actually don't know what Scaleway is and who we are as an actor. So let me just start with this. Scaleway is a cloud provider, actually. So we do provide cloud and AI products and also manage services for different users in Europe. We deliver a secure and reliable environment for the most demanding clients in Europe. So which type of client? Well, we have big public companies such as Ministère de l'Intérieur, but we also work with people like H100, and of course, very famous AI actors you for sure know, like Face or Mistral AI, Qtai, and Photo. We are a French and European cloud provider. That's what makes us special. We are owned by a telecom giant, which is called Free from the EDL group. And this positioning of ours, French and European, is enabling us to provide you with immunity from extraterritorial legislation, thanks to data sovereignty, GDPR compliance, and local footprint. On top of being a French and European cloud provider, we are even backed by the French government itself. So we had actually the honor and pleasure to have the French government during our AI Pulse first edition, this great event about AI that happened in last November. And we are really supported and backed up by the government itself. But, that's not today's topic, right? Today's topic is about H100. So the idea today is to go through 3 different points. First of all, I'd like to go through the specs, the hardware specification of the H100 GPU instance for you just to have a glimpse at it and understand what's special about it and why we've been talking so much about this new disruptive, new product, new GPU. Then with Anthony, you'll go through a performance benchmark of this instance that we have at Scaleway, and you'll see by your own eyes how good it is for what type of workload. And then you'll end up hearing about Diabolocom journey, thanks to Andrey testimony, hearing about their infrastructure, what they did with this H100, and for what it was very interesting and different from other GPUs. So bear with me, it's 11, so I think we can start talking about the GPU H100. So as you, I guess, may know, H100 comes from this new architecture NVIDIA created, which is called the Hopper architecture. What's new about the GPU is its architecture itself. You have a full white paper about it on NVIDIA website that is quite interesting. But to sum up the new innovation within this architecture and explain you the big benefits it has, there is this one slide that is trying to recap all of this. So why the hype about the H100 GPU? Well, because NVIDIA presented it as a GPU that is 6 times faster than its predecessor, the H100 PCIe here. So what's so interesting about it? 4 things here. Well, first of all, it comes with 80 gigabytes of VRAM, so of GPU memory, which makes it the product that can actually the largest models and data set ever can be put in a single GPU for the first time. This is the biggest GPU memory of a GPU. That's the first time we have 80 gigabytes of RAM here. It makes it very interesting to train large language model. Then you have the 4th generation of Tensor Core. This 4th generation is enabling this GPU to be accelerated. So now you can reach speed of 1,513 teraflop in FP16 or 326 teraflops in FP8. The third thing that is quite interesting is the new transformer engine that is also enabling this machine to actually accelerate AI inference and training to up to 30 times according to how you will code in what data format. And then another peculiar feature that you will find on this GPU is the MIG, so multi-instance GPU feature, which allows you to partition your GPU in order to maximize the usage of each workload on the H100 itself. You can actually partition it up to 7 partitions, which makes it a very flexible GPU and really help you maximize your infrastructure globally. And I think you'll hear more about it during Andrey testimony, because he's been using this, and I think he's been kind of loving it. Another thing that is important for you when you're going through this H100 question is to understand that there are several types of H100s, defined partly by their form factor. So you may find on the market H100 S6M, H100 PCIe, H100 NVL. This differentiation is quite important because it impacts the speed, the bandwidth, the TDP, and the server option that you may find for the instance you're looking for. Another thing that you need to have you need to watch out is the interconnection that you may find that will be available in these GPU and offered by a cloud provider. You have NVLink or PCIe Gen 5, so it's this line here. And this is impacting the way GPU will communicate between them, so which means it will also have an impact on the distributed training performance if this is important for you in the way you're building your infrastructure. Which then leads us to the instance available at Scaleway. So at Scaleway, we have the H100 PCIe GPU instance available. This instance is made to accelerate your model training and inference with, as you know now, the most high-end AI chip available on the market today, and for 2.52 euros an hour or 0.042 euros a minute. It goes with all these specs here. You can deep dive into it. You can go to our website to know more. There's a product page dedicated to this. And you can also actually share questions on the Q&A for the Q&A later right now. So feel free if you have any question at that point to share it with us. Last thing you need to know is that it comes in 2 formats at Scaleway. You have a standalone and a dual GPU instance. So either an instance with only 1 or with 2 GPU communicating together. So that's for the hardware part, the specification. Now you know what within the hardware makes this product special, what was actually the hype about. So let's move to the performance in real time and in real workload. Through this, we've done great benchmark with Anthony from Cloud Mercato about several use cases. So Anthony, could you tell us a bit more about it?
Yes, sure. Thank you very much, Constance. So just to give you a context, I'm Anthony from Cloud Mercato. So we are a consulting and research firm dedicated to the study of the cloud market. And our idea is that there are plenty of cloud providers. And we would like to highlight more than AWS, Google, and Azure. And today it's for scale. And so, like Constance showed, there is the H100 is a good step in terms of performance for the end user. You have the latest generation of CPU, and like she showed, we saw the spec, we saw the NVIDIA declaration, but at Cloud Mercato, we love to do independent benchmark because we can trust NVIDIA assertion, but we would like to have real data to assert what we need. And if you go to the projector.cloudmercato.com, you will have several projects that we did to evaluate the different cloud products. So let me share my superb screen with you. So we're gonna see it. Hopla, the screen number 1. So we got it. So the goal of this benchmark was to evaluate the H100 performance against other kind of GPU. So we have 3 workload like you can see: Invoke AI for image generation, Oliama for GTP like AI, and Whisper to do speech to text. Excuse me. And we evaluate this workload with different GPU, from the old Pascal to the Tesla to the Ampere to the latest generation of Hooper that we selected in the different actors that you can find in the cloud market. So we took GPU from Google, from AWS, from OVH, and of course from Scaleway. And as Scaleway at this moment was the only one with H100 PCIe, you can differentiate here the Scaleway performance with the purple bar. So you can consult again the project by yourself. Just go on the web page and you will see. But we're gonna dive into it together. So if we take the first scenario here, we get Invoke AI. So the question is, how quickly can images of different size can be created? So by different size, I mean here 32 to 32, but we go up to 2K to 2K, so an image of 5 megapixels approximately. And as you can see, the H100 is always the best in terms of performance, always the fastest. There is maybe the A10G, which is one of the latest Ampere that can compete. But at the end, when I would like to have large images, only the H100 can produce a large image in decent time. So smaller image, it's cool. Larger image, H100 seems to be a requirement. And if we go to the next topic, Oliama. So here the question is, how fast, how quickly can the computer, the AI answer to my question? So I give a question, how much time it will take to get the answer. Here, there is no doubt. The H100 is clearly better than the other. And I will say above that just the performance, the things that the H100 has 80 giga of RAM change everything. Because with Oliama, for the largest model, you need to have a lot of RAM in your GPU, else you just cannot launch the model. And here you can see that the H100 is good and better than the other with the small model and the medium model. But for the large model, clearly the H100 is better than the other, and is inside the list of the only GPU that can launch this kind of workload, because again, you need a lot of RAM to run this kind of workload. If we take the latest scenario, so Whisper, speech to text, I could do the same conclusion in the previous test. In fact, Whisper, you can see that the H100 is better in terms of performance. Here for Whisper, the AI model doesn't need a lot of RAM to be launched. So any kind of GPU could launch it, but everyone can launch it, but everyone cannot launch it at the H100 performance. So I repeat myself, I know. H100 is better here in terms of performance, in terms of specification. You can see that compared to the rest of the market, we really move a step ahead. And yes, you can consult it by yourself on this website in Cloud Mercato, projector.cloudmercato.com. Go by yourself, and you will have all the result by yourself in shape of a graph, in shape of a table. And of course, you can also download it by yourself and run whatever you would like to do in Excel. Voila for me. If you got any question, do not hesitate, write it on the chat section. And I think I will pass the mic to Andrey.
Okay, thank you, Anthony. Okay, so I will tell you about our journey with H100 in Diablo.com. My name is Andrey Drozdov, and I'm a MLOps engineer at Diablo.com. So before we start, I will quickly describe what is Diablo.com and why we're doing AI. So first of all, it's a cloud call center, and there are a lot of multiple features like custom routing and many things that you can do with phone numbers and phone call routing. Now we have dedicated data centers in European countries, so we're matured companies, and we have a lot of customers, as you can see in the slide. And the most important, we have full in-house PBX solution and AI solution. And the workload is about 800,000 calls per day, so it's quite a lot. And a couple of years ago, we decided to go with AI to do some kind of analysis for calls, because the AI analysis in the call center is, it's not even the future, is present, and it's very important to keep the quality of the call center and basically quality of the calls in your company. I will try to briefly describe the idea of what we are doing in super basic example. Let's say we have a typical conversation when somebody is ordering pizza, and this is a typical example of phone call. So customer is calling to the agent, he's saying, hello, I need a pizza. Agent is asking which pizza he prefers, and so on. So basically we have some details about the order. There is a promo action, like you can get Coca-Cola for free. Then agent is asking for delivery address, and then agent is saying something a bit risky, because agent saying pizza will be delivered in 10 minutes or we will return back money. So it looks interesting, but it creates some risk for the company, and we have to monitor things like this. So what our AI product can do, it can basically analyze all the conversation and understand some important points, like where is the call opening, where is the ordered items, promo item applied. It can extract delivery address, and we can detect things like risky promise, let's say. And in general, we can detect anything related to call script, or detect advanced things like promo items or additional events that may happen during the conversation. So, and on top of that, not only just analyze one call, but analyze all the calls in the cloud call center. We can do some aggregation, like per time period, per team or department, per products, or everything is needed, and then do some advanced analysis after the call, like clustering, call script validation, the custom events that I mentioned, and even trends detection, so managers can easily understand what happens in the department, what people are talking about, which problems do customers have, and so on. And of course, on top of that, we can do some reporting, like agents performance, risk management, brand protection, and of course, quality control. As you understand, this problem requires a lot of resources, and when we just started with this product, we got some ideas and requirements how it should be done. Basic idea is just to have a like PBX on one side. There are some calls, and of course we can store all these calls in some audio storage. So first important thing, this audio storage should be in Europe. Second, we want to use this audio in order to train our own machine learning model to do ASR and speech to text, and then some analysis. And at the same time, for new calls that are arriving, we should send a task to the queue and transcribe the call and do some analysis after that. And the same idea, but more advanced, not just post-call, but real-time. It means that we can do some suggestions for the agent during the conversation live, and probably calculate the probability of some successful operation like sale or everything related to the conversation during the call. So it's much more advanced and it requires much more resources, computational resources. So here you can see the schema, the difference between real-time and post-call. You have a streaming service and custom protocol that PBX can stream the audio to the server. Our ASR worker can immediately transcribe this little batch of text, and then LLM worker can do some analysis on top of that. In the end, all the results are streamed through the WebSocket to the interface, and agent can get some insights during the conversation. This was a basic idea, but there are a lot of details under this, and we prepared some requirements. What do we need to implement this? So first of all, of course, we will need a lot of GPUs because all these computations are super heavy, and we should have strict SLAs for post-call analysis, and of course, even more strict SLAs for real time. So the latency should be less than 500 milliseconds, and that's why we need GPU. Second, everything should be scaled because we have different workloads, different customers, and moreover, the working day may start like at 9 or 10 and end at 7 or 8. So we should upscale and downscale everything every day, and it should be very easy. Of course, we need to run all our services in a predefined environment, and it's a good point to have everything in a Docker-like system or containerd. Because I mentioned the queue for task, we should have stable queuing system for post-call analysis. And because I mentioned in previous schema a couple of storages for models, for audio recordings, we should have S3 compatible storages for this. And of course, all the processes in the system and in all the services should be covered with metrics, with tracing to do fast troubleshooting, and in case of incident to quickly find the problem and find the solution. And in the end, we should have, of course, Grafana dashboards to monitor all this metrics and tracing. And the most important, because we want to have 100 percentage compatibility of production with other environments, all this environment should be easy to duplicate. And if we want to have a staging which is 100% same as production or benchmarking cluster, we should not have any additional setups for that. So what solution we found from our side? Basically, it was Scaleway, because when you start a project related to GPU, even if you have your own data center, it's much easier to start with a provider who already have experience with that, because it's quite expensive to buy a lot of GPUs to maintain them. And plus, we can use some advantages as Scaleway is providing. Okay, first of all, it's NVIDIA H100, which is great GPU. Second, it's managed Kubernetes, which is exactly fits our requirements. Because we have Kubernetes, we can use Docker for containers. For stable queue, we can use NATS.io, which is also a managed solution by Scaleway. There is a S3 compatible storage and block storage on the Scaleway cloud. And there is a solution with Grafana Mimir to do protobuf metrics channel, which is very useful for us because we have a lot of metrics. And there are a couple of solutions for tracing. but we are using custom open tracing Jaeger deployment in Kubernetes. And in the end of the process, we can use Scaleway cockpit in order to do Grafana metrics and dashboards, which is very useful. And because in Scaleway you have multiple projects, you can basically duplicate everything you deployed in another project. So it will be perfect match for our requirements. We can deploy production staging and other environments if we need. And this solution will add one more option because we will have hybrid cloud solution. And basically one part of the system will be in Diablo.com data center and another part will be on Scaleway. So how it looks in practice. But before we will see the schema, it was an additional thing about Scaleway support. In the beginning, when we started with the project, we used SQSQ before NATS.io, and it was one limitation that we are able to do only 10 queues per Scaleway project, but because we're a majored company, we have more customers, so we need a bit more instances. And it was very nice that Scaleway team helped us to basically do the benchmarks and get the best value from our cluster. And together we migrated to NATS.io, which helped to solve all our problems with queues. And now we have unlimited queues, and it's easy to deploy and manage as SQS. So it was great. And basically how it looks. So on the left side, you can see the one rectangle with PBX, but as you understand, it's a complex system with multiple clusters deployed in Diablo.com data center. And at the same time, we have some applications with the interface deployed in the Diablo.com data center as well. And on the right side, you can see Scaleway Kubernetes cloud, which is deployed on Scaleway. And here we're deploying our machine learning and AI facilities, such as GPU workers for speech recognition, for large language models, and some storages for models and for audio. And there is a secure channel between two data centers, and here is how it works altogether. Of course, the most important question of this project is computation and computational power. That's why we have to discuss something about GPU. But before we start, just to understand why GPU is so important for this kind of project, because everything that we are doing with modern neural networks and solution like LLM or speech to text, Anthony already mentioned Whisper and Llama. All of these solutions are using mathematical objects called tensors. So imagine like a 3D or more dimensional matrix. And all that we need to do is just to do some computation with these objects, basically like multiplication, addition, or anything you need to do with multidimensional matrices. And if you take a look on any architecture of modern neural network, for example, here you can see the ASR. On the right side, you can see the schema. On the left side, you can see the basically algorithm how next token is calculated. You are doing a lot of operations on each layer, and each layer is a big set of numbers, and basically all inputs and outputs are tensors. Then they can be transformed into the tokens, and basically the ability of how fast you can work with tensors, it means that are you going well or not, and that's why you need GPU. Basically for speech recognition, you can see you can get the spectrogram of the audio, maybe slice your audio on some chunks, basically just to find where the speech is. And sometimes you can use VAD, voice activity detection, for this. This is additional model which is may use GPU as well, but it's a topic for another presentation. Anyway, you have some encoder blocks, and decoder blocks, and in the end you can predict a particular word in the end of this process. In some older versions of speech recognition models, you may predict phonemes. Then on top of this predicted phonemes, you can build the lattice graph and use the shortest or basically the most expensive path in this graph to predict the full utterance. But anyway, we understand that it's very heavy operation and we need a lot of resources for that. Moreover, if we are doing real time, it became even more important because we have very short time slot to produce some output. The same with large language models. So now it's a very popular technology with self-attention, multi-head self-attention layers. On the right side, you can see principal schema of self-attention layers, and on the left side is a simplified schema of LLaMA model. So you have token embeddings as the input, then you have many layers, including self-attention, and then you will get output token embeddings. All of these are tensors before you decode basically tokens to the LLM input, and the output is tensor as well, and you decode them back to tokens after the inference. And here is why GPU is allowing you to make it faster. If you look on this slide, on the left side, you can see a typical CPU schema. So if you have 4 cores, you have just 4 instances that can help you to calculate something. And on the right side, you can see typical GPU setup when you have a lot of cores. So you can do a lot of parallel computation, which is the best fit for our problem with tensor mass that we are doing in order to do some inference or for some training. It's not important. And that's why we need H100. Now about one feature of H100 that was very useful for us. As Constance already mentioned in the beginning of presentation, we can use MIG partitioning for H100 in order to split this GPU on some virtual GPUs. And on this slide, you can see 3 virtual machines with 5 different applications that are using some virtual GPUs. And it means that you can pay for only one GPU, but use it for multiple applications. And in practice, it means that if you are able to deploy your production model, and then after some times you will optimize this model, maybe do some pruning and remove some unused weights, or find just a smaller model that fits less memory, you can get up to 7 times infrastructure cost boost for the same money and with the same performance, which is super valuable and can help your business a lot. So we're actively using this feature in Scaleway Cloud. I mentioned that we're using managed Kubernetes, and at the same time we need GPUs. So it's very easy to do this in Scaleway. So when you deploy a cluster, let's assume you already have your node pool, you have configured cluster, and you're running your microservices or some other systems like Q consumers. If you need to create a GPU, you can just add one more node pool, which will be like a GPU worker pool, and add just one additional parameter to your specification. And basically your GPU will automatically join the cluster. You can partition it for a couple of virtual GPUs if you need. And then you can just use your default specs for Kubernetes and deploy the application. Here is the example. So this is typical Kubernetes spec. So we can define how many replicas we want to run. We should set the node selector that we want to use GPU product. And important thing here, we have amount of virtual video memory, VRAM, on your NVIDIA instance. And when you partition your H100, you should have exactly same partition. So if you split it like 1 plus 1, you will have 40 gigabytes per instance. But you can split it, let's say 3 per 20 or 6 per 10. And basically you can deploy all your applications on one instance in this case. And in the limits, you have to put NVIDIA GPU 1, which means that we are enabling GPU mode. And that's it. So it's super easy. And then you can run your application. One more important thing that was our experience, it's open tracing. When you have huge system, which is running more than 50 services, and you have integration with another data center, which is not in this cloud, it's super hard to troubleshoot things and find answers quickly. And open tracing is a super solution for this, because you can track not only every service that is doing the request, but even every function that is running. And if something is going wrong or something is crashed, you can find exact place when it happens, where it happens, and which team is responsible for that. So it's very important for good quality infrastructure. And of course, the cockpit can show all the metrics. So here you can see, let's say, ASR decoding ratio, cluster tokens per second in terms of LLM, and other metrics, which looks quite beautiful. And for some numbers, we did the benchmark with some publicly available models that you can use in your project. So basically, we have a special data set from a big retail company from France. And for this benchmark, we sent this 30,000 calls to our system and do full analysis, which means transcription plus some text analysis on top of that using LLM. And here you can see some details about the benchmark. So first one was the Whisper CPP, which is ASR. And you can compare like max performance setup when you have a low tuning of your model and trying to produce as many calls as you can. And max quality setup when you have the biggest beam size and basically parameters optimized for the best output and the best word error rate. And the same for large language models. So here is basic LLM model downloaded from Hugging Face using Llama CPP engine. More fancy Mixtral Instruct model available on Hugging Face as well. And the Mixtral model based on NVIDIA TensorRT technology. So you can see that for basic LLM, it's quite fast. It's about 500 tokens per second. For maximum quality is a bit slower, but it's expected because it's already a lot. Of course, Mixtral is slower, but there is a reason, because you can put a couple of megabytes to the prompt. You can put JSON schema for the output. You can put full text of the call and all the tasks that you want to solve. And only one LLM will solve all your requests. And sometimes it's reasonable to use a slower LLM, but solve more tasks and use more VRAM for this. The NVIDIA TensorRT is faster, but it supports less model, let's say, than Llama CPP solution. Anyway, it's very, very strong results and good performance for LLM. And that's why H100 is super useful for this kind of calculations and computations. So final numbers that we are able to get for our production systems is about 100,000 minutes of transcription and analysis during working hours of the call center. It means it's not per 24 hour, but for 8 or 10 working hours per day, so they are more compact. And for us, it's a great result. Here I can say that, of course, GPU can be a bit expensive, but the values that you are getting from them in terms of performance boost and real-time opportunities are super nice. So that's why it's very useful for us. And some takeaways that you can get from this presentation, if you will decide to go for H100 in production and do some machine learning in a Scaleway cloud. First of all, H100 is super useful for partitioning, and because of that, you can run up to 7 containers in one GPU if you have compact models. And this is super efficient in terms of infrastructure costs. So I think it's number one. Then if you are newbie with Scaleway, you just need 3 lines of code in Kubernetes spec and 1 click in UI to deploy GPU. So it's easy to start and easy to do some experiments before you start developing. Second, important things that we already did benchmarks and we're running in production. So we can say that Scaleway Kubernetes plus GPU and H100 is a stable solution for production, which is very important because sometimes you can see some fancy technologies, but you are not sure that is it really good for production? Is it stable? So for us, yes. Then you can use Scaleway Cloud as part of your hybrid cluster solution. Like in our case, we have our own data center, but we're deploying part of our infrastructure at Scaleway, which is good for maybe medium-sized or big-sized companies. As I mentioned before, open tracing will help to solve a lot of problems in big distributed inference systems. Much faster than just grabbing the logs. And the last one is a point to say thank you to Scaleway support for solving all our questions and for very fast and responsive way of working. And in addition, if you have some kind of VIP support, they will not just answer you, they will try to help you to get the best value from your Scaleway setup, and thank you for this. So I think that's it from my side. And I will pass the microphone to Constance, maybe.
Yeah, with pleasure. Thank you so much, Andrey. So super interesting. I think it's time for Q&A, but I think we have a shy audience today, so no question yet. However, listening to your pitch, I wanted to ask you, Andrey, how was the experience using this MIG partitioning feature for you? Was it the first time, and how did you succeed in doing this? Was it simple, not simple? Like, what do you think?
Yes, so I heard about this before, and I was reading some documentation, but I never used it before Scaleway. It was very easy because when you deploy in Kubernetes, the NVIDIA Kubernetes operator is deploying automatically. And basically all you need to do is to apply one command and describe how exactly you want to do the partitioning. And in reality, it looks like you click button in the Scaleway interface, then the GPU was joined to the cluster. And then you say like, okay, I want to split this GPU on 2 parts or on 3 parts. And it's doing the split almost in a couple of seconds, so it's fast. And then you can do and apply all your kubectl command to deploy whatever you want. So, and that's it.
Okay. Well, about this topic, there are 2 things. Let me share with you this little tutorial about how to launch your GPU H100 PCIe for the first time. And I've just shared in the chat also a link to our documentation to try MIG, because we've been talking a lot about this feature. So if you want to get your hands around it, here are the two things you need, I guess, to get started with it. But okay, very interesting to hear this about your experience, Andrey. Thank you so much. I have one other question. I hear lots of time that it's not that simple for teams and experts to actually quantify correctly and choose the type of GPU they want to use. So I guess the problem is actually quite the same when it comes to partitioning it. Like how do you know? Do you have any advice, any tools, any techniques you'd like to share to help people figure out, well, to do this, if I split this into two, it's going to be enough or not? Like,
there are two suggestions and ways to do it. So one is more heuristic. You can say that if you have model weight equal X, you should have X VRAM plus maybe 30% to have some space for computation. This is simple way because you just calculate this and do the partitioning. But more, let's say, scientific or engineering approach, you are doing benchmarks. So it means that you deploy your model and you try to use it for 100% of GPU or CPU. It depends on your setup, and you find the moment when it fully dies, and you will completely understand when you can use this model, or maybe you need better partitioning.
okay, interesting. So benchmark again. And I guess my last question is going to be about the benchmark itself, right? Because during the preparation of this call, you actually, Andrey, had one question for Anthony about this benchmark. So could you repeat that question? Because I think that's quite interesting, right? We've been hearing performance report and big taglines about the H100 that are quite different each time, because I guess benchmarks are different, which is important to understand, like how different it is. So if you could ask Anthony the question you asked again, that would be, I think, valuable for everyone in the room. Or you don't remember the question?
If I remember well, Andrey, your question was about the unit that I use in my benchmark for Whisper, and the unit that I used was is the token or the frame per second. And you told me that it's not the most accurate unit that I could use for report my things.
Mm-hmm.
But yeah, could you redo it? Maybe I'm wrong.
No, it's correct. I was asking about this, but Constance was asking very good question, because when and it's related to your previous question. If you are doing benchmarks of something, it's not even related to GPU, but in general, if you have some numbers in the internet and you can find some articles or publications or YouTube videos, you should always think that this is synthetic benchmark, even if it's not. Because when I showed the numbers, it was our custom data set that we are using based on our data. And let's say the length of audio was specific, the content of this audio was specific. And if you are taking some synthetical benchmarks, it will be fully perfectly sliced audio, and the performance will be completely different. About metrics, so it's true that correct way to measure some ASR, it can be frame per second. At the same time, decoding ratio is correct as well, because it basically shows you the difference in speed. But it's good practice to fully understand and define what do you want to measure in your particular case. Collect your own data set, which is close to your real production or your problem, and then do the benchmark. In this case, you will have the best output for your setup, and hopefully it will help you to solve the problem.
Yes, sure. And as you said, a benchmark is somewhere you take, you put a context, and so you filter the perspective given to the user. But I hope with my context, with the panel that I choose for this benchmark, I hope and I guess for sure that it's neutral and objective. It's still neutral and objective.
And I guess, yeah, absolutely. But there's no question about it. So I guess it's clear enough, or people will have a look at it. Just remember that I guess the purpose of the benchmark and the decision we took and Anthony took to make it was with one objective in mind: to compare the different machines together and see have a comparison point. Like that was really the point of it, not getting into the best performance it can go. I mean, that's another type of benchmark, I guess. Okay, well, that's my question so far. Thank you so much. I don't see any other question from people, so I think it's been clear. But remember that we are here to answer any question you may have, so you can get in touch with us, like through Slack channel. You can get in touch to LinkedIn. Don't be shy. It'd be a pleasure to hear you out and understand what was interesting for you in this and what you want to know more about, more use cases, more information about the specs, more information about benchmark. Tell us. It's time to wish you bon appétit. Enjoy your lunch. But before leaving you, if you're interested about other webinars hosted by Scaleway to better understand what we can provide you with, you have a masterclass on getting started with object storage in 30 minutes. In a few days, you have a cloud cost optimization for SaaS infrastructure webinar happening also on the 20th. And you have on the 29th, mastering your cloud migration, Green Soul success story. So another success story based on another use cases. So that's it for the upcoming webinars. And last meeting and almost rendezvous I want to give you, because it was Valentine's Day yesterday, right, is to meet us at AI Pulse, the second edition. It's going to be on November this year too. So if you want to keep posted about this, if you want to know more, and if you want to be there, well, just follow our newsletter and you'll get all the information you need. Thank you so much for your time. Thanks, Andrey, for these insights you've shared with us. Thank you, Anthony, for the work and for presenting this that well. Thank you for the secret agent, Fabien da Silva, the PM AI at Scaleway, who's been building this GPU instance and was there all along to answer your question if you had some. And thank you, everyone, for being here. It's been a pleasure to have you. I hope we'll see you in another webinar very soon.
Thank you so much.
Thank you, Constance. Thank you very much.
Bye, everyone.
Bye. And thank you, Fabien.